Okay, so I just want to talk a little bit about the Python and give you some tips. For one thing, on this, start at the beginning and do this code and type it in, and so don't just skip to the end and go through the whole process. But basically, what's happening here is that, and I want you to think about um, when you may have heard this. So what is I, right? In this case, I equals one. What is I? And the answer to that is somebody say, well, it's a variable, right? You could change its value. That was the flat way of looking at the world. In in the in the procedural programming days, okay, when our languages were very much a compiled and very simple. The new way of looking at this is I is an object, okay, and so I is a thing. And it's like Dr. Seuss, thing one and thing two, right? So it is a thing. It is an object and it has a type. So in this case, or in the Python's case, it has a class, right? So it is an int or an integer. It means it stores a numeric value. But because it's an integer, I can do quite a few things with it. Number one, I can use operators to increment its value. Right, so that's what I'm doing here. I'm adding one to it. If I try to do this with a different type of value, in this case a byte, right? So this is not an integer, it's a byte. And a byte is simply a piece of data, right? It's just a new piece of numeric data. In this case, a byte is a representation of some value. When we look at files, and I have some files here. What we're actually doing is we're taking a binary value, and we are transforming it in some way, and we're displaying a character on the screen. And so when you look at this character right here is not just a lowercase b. It's actually a binary value with a number, and what we can do is and you've seen this before, we can take this value and we could represent it in two numeric characters called a hexadecimal value, and that's the way the byte is stored. So in this case, what my code is doing is it's actually telling it's creating an object A, and that object is going to store a byte value. So it starts it with a B, and it tells it, okay, what you're about to see is a byte. And I could easily say, I would like this byte to be, the letter A. It could be any other visible character. So I'm going to just go in here. And now I could say that I want it to be 25, 186. Okay, here we go. All right, here's 185, right? This is a little, what is that? Right? It's a little box drawing object. There's 189. I think this is 186. 186. Yeah, that's 185. Okay, 185. That's 189. Right? These are decimal numbers that correspond to these particular characters right here. So the way I get that is I hold down my Alt key like this, and I put in the 3-digit number, and I get this character representation of that 3-digit number. So in the world of bytes, right, if I had an A in a file, what I would actually have is the hexadecimal representation for, I guess that's 65. So let's see. 0.065. Yeah, A. So what's 0.065? Well, that is a decimal equivalent of a hexadecimal number. So if I go to, see, 65, I can see that it is hexadecimal 41. And if I were to put in 189, I can see that it's hexadecimal BA. That's that's basically that's 11 times 16 plus 9. Right? We can do that. Plus, sorry, 11 times 16 plus 11. That should be 187. So let's see if it's 187. Let's see. Oh, it's 187. No, okay. So that's 189. So, 189 is BD. I think I got the wrong. I got the wrong number. BD. Right. So 11 times. Um, A is 10, B is 11, C is 12, D is 13. 11 times 16 plus 13. All right, I'm doing some quick conversions so you can see how that works. So 11 times 16 plus 13, 189. Right? This is my decimal value. This is my hex value. This is my Unicode character that I'm looking at. And so if I were to store this character in a file and I were to read it, and I were to read it as a byte and then access it as a number, I'm going to get this number, 185 divided by 16. Okay, so when I store these characters, in this case, if I store an A in a file and I look at it, and it's going to be number 65. If I store X41, it's going to be I'm going to access it as a number. I'm going to look at it as 65. So that is just the way this actually works when I store these byte values. So I'm just happen to be storing number 1, which is not necessarily a printable character. If I try to look at it as an alt001, I get nothing, right? It's not a printable character there. There's nothing there. So printable characters don't start until later. But so that's just a way you can check and you can see, you can actually look and see, well, what character am I looking at, right? If it's in a file, if it's in a binary file, and you see a whole bunch of characters, and I can look and see. Let's see, I think I downloaded a file earlier from one of the files here, so I'm going to look at it and. Right, so that particular value is unprintable. right? That's why it's right here. It does not correspond with, that's printable as a space, but this particular value does not correspond with something that can be printed on the screen, but it is still numeric. And so we're reading that in, and then we're accessing it as a number. Okay, but I wanted you to see that so you can kind of see what's going on. We got several different things happening here. And when I look at this code, and I'm actually using that /x, I'm creating a hexadecimal value in there. And that is, the computer knows now, okay, this particular value is going to be hexadecimal. But if I were to access it and use its individual item, I would be using it as a number. So we'll look at it right here. And let's see, let's set A equal to the byte value. We're going to call it a hexadecimal value, 65. We're going to print A. And notice that it gave me the letter E, the little letter E. But if I were to say, if I were to do B equals, equal B equal 2, it's unprintable. So Python automatically knows I can't really show you that, right? And so 65 hex, that is what we're telling it. So if I go to here and I type in 65, I'm giving it decimal value 101. Decimal value 101 is a little e. So that means that when I actually access this, like Sam did here with a subscript, and if let me set my value again, A equals B 65, and I'm going to put the actual character itself in location 0. There's my value 101, my decimal value that equates to the printable character E. So that hopefully will give you a little bit more background information on using this code right here. And when we get into files, effectively what's happening here also is that this file it's going to, when we use the with keyword, we're actually creating an object, and that object is a file, and an object is going to be called f, right? And so now we can do different methods on this object. In this case, the read method. And the read method is basically like inputting, instead of inputting from the keyboard, I'm going to input from the file. The one there says just read 1 byte. Okay. And these particular files that we created, in this case in file, it's HELLO, right? If I read it as that character, effectively, I'm printing out each byte. Now remember, these are numeric, so an H in bytes is going to actually have a decimal value, right? And if I were to access it with a subscript, I'm going to get the actual decimal value of these characters. So let me see if I can find my code where I did that. Let's see. I made a file called infile. And I think I called it file 1. So let me see here. So I'm going to print the byte, and I'm also going to print the byte at a subscript of 0. And we're just going to loop through this file. So we're going to read a character, and we're going to access the 0th element, right? And what it tells us is it gives us the decimal code, right, of each one of our values. Right. So that is that's a little trick there that we can see. Now I'm actually accessing the file, and I'm using that file as an object f. And so if I were to use it dir f, I could see some things about that file if I wanted to. I don't know why it didn't give me that information. Let's see, print. Gotta remember to do print. And let's see, PIRNT. And as you can see here, right, so these are the methods that I can actually call on the file. So you can look at those methods and find out how I want to utilize this file. I can do all kinds of things with it. In this case, all I'm going to do is I'm going to read one character from it. And so that helps me actually go and do this project right here, right? Which is where I'm actually going to count these characters. So now that I know how to manipulate this, right, now I can actually do some code that will help me do it. So I went ahead, let me open my code. I don't know why this defaults to the same working directory every time. I just wanted to look at the last place I looked, okay? That would make it easier. And let's see, I think I did a file 3. Yeah. Okay. So here's what we did. We opened our file, and then we read in the bytes. And what we're doing is we're looking at this character to see if it is equal to nothing, right? But it's not. So I'm going to check and see if it is equal to this hex value 08. And I mean, there's a lot of different ways you can do code, right? So what I did was I kind of debugged myself, and I wanted to see for sure that I actually found it. So I just printed found every time I found one, and then I incremented a counter. That's it. And so at the end, I printed out the number, and that's actually the answer to the flag. But doing this and looping through these values and forming a good if-else block is going to help me, right, as I start to do this one, which is a little bit more complex. And so, not too complex, but it's a little more complex. So in this case, we're gonna basically do exactly what we did up here in our options, where we actually opened two files, and I read the file. I checked to make sure that it wasn't empty. Then I printed it to the screen and I wrote it to the next file, right? And that's basically all I'm doing. I'm taking something that's coming into the stream and going out. So right here, I just took the code and I read the file and I read in each file in turn, right? So what I knew when I looked at these files when I downloaded them, and I knew that they were. Let me go. Let me see. I knew that these files, that is a big size, right? That's not the right size. If I look at it here, it's only 24 bytes, okay? So I said, let's see if these are the same size. Just gonna look. No, it's 24 bytes. And that one's also 24 bytes, right? So here's my problem that I get to. I want to download the two files, add the bytes in the two files together to construct the flag, right? First file contains hex 40 and the second file contains hex 01. The result is 41. Problem is that when we look at the files, not all of them contain hex values. When we read them in, they look like something else. So they're just, some of them are just bytes. Some of them are hex values and some of them are bytes. And so what we have to do is we have to think, well, how can I add these together? So here's the way I solved the problem, right? I checked either file just to see. Now, supposing that if I'm going to add the two files together, what if one's bigger than the other, right? What if I run out of file before I have another one? My whole point was I got to end this at some point, so I would just go ahead and end it if any one of the bytes were empty. In this case, that's not going to be true. And so I wanted to make a little table, and I wanted to just see what happens. And my table is not perfect, mainly because when there's some empty strings, it doesn't tab over all the way. But I just wanted to see what would happen here if I were to show the actual byte that I read from the file, and then I were to actually look at the numeric value in the file, which may or may, see, this is always going to be an integer. This may or may not be a hex value. This will always be an integer value. So hex 13, right? And then I tabbed over and here's value 19 is the numeric. But it's not a character that can be printed. This one here in this file too was A. Right? It was a byte value A. It wasn't a hex file. It wasn't a hex. But when I look at its numeric value, it's 65. So because I've accessed these two values using the subscripts, now I can add them together. And so that's what I did here. Byte 1 subscript 0 plus byte 2 subscript 0. And then I just converted. I used a function called CHR to convert that sum to a character because I'm not going to store this. I just want to read it, right? So I get the flag is, and what is it? ADDING underscore BYTES, right? I just added these values together. So this is hex 19 and decimal value 25, and we can actually use the calculator. hex 19. Right, there's a decimal 25. Right, we can pick any of these out. Hexadecimal. Let's see. This was 66. So if we converted that 66 to a hexadecimal, it would be 42. But effectively, 66 plus 5 is 66 plus 5, 71. Right? So if I were to assign that value 71 and look at the character there, I would see this this character. And so, a lot of times as humans, we think about these characters as they actually contain some meaning, right? A is A and B is B, but A is just simply a symbol, right? So we have to sometimes think about this like we were a computer, right? I'm just outputting symbols. And so adding bytes is the code. And actually, now that you see how to do this, this should be if you combine, right, the fact that I'm going to add these up and I'm going to write it out to a file, and then it says, open that file in an image viewer to see the flag, right? So you can do that as an exercise after seeing how to do these. And so the code is there, and it's very straightforward, right? I'm just using the CHR function. I'm accessing the bytes as a subscript and I'm adding them together. And then I would simply write it to a file. And so you can use add another program. Let me open that up. I think I did it in file 2. Yeah. So here's file 2, and this is Sam's code. I opened the file, I opened the output, I read the file in, I checked to make sure it wasn't empty, and then I wrote it to the file, right? And then I read the next character. So that's it. And then you would open that file in a text editor. So I'm going to go here, and we'll open up, if we created a VP 110-3, I would open with Notepad, or actually open it with an image viewer. So let's just say I did that. Let me show you what I would do. If that was it, I would go ahead and I would copy it, and then I would paste it, and I would rename it. JPEG. And in this case, what will happen is that it will actually show up as a file that I can see. If I have a problem with it, I can load it up. In Paint, maybe. Oh, it says PNG. Sorry. So PNG. So let me rename it to PNG. Now this is a different one, but so this is what I would do on Python file number 110-3 PNG, and it's going to show me the key, right? So that is how I do that. I'm going to let you do that. All right. Thanks.